14 and 10. No, it can't be 14. Can't be 14.
Pause! Here we go. We're just going to go in order. Group number 1. What was the problem for number 1?
X squared minus 7.
Minus 7x minus?
18.
What did you guys get as your answer?
X minus.
X plus 2, X minus 9.
Everybody else, do you agree?
Yes.
Did you have to go any further? No. Because it did not say find the zeros. Just said factor. Number 2, group number 2. What was the problem? What did you guys get as the answer?
P minus 7 times.
Everybody agree?
Yes.
Yeah. Yes.
Nice. Group number 3, problem number 3.
M squared
M squared
minus 9m
minus 9m.
plus 8.
How'd you guys factor it?
M minus 8, M minus 1.
Do you guys agree? Group number 4, problem number 4.
X minus 7.
Oh, what was the problem? Sorry.
X squared minus 16x plus 16.
Plus 16?
63.
Oh, that makes more sense. I was like, that's weird. Okay. And how'd you guys factor it?
X minus 7 minus 7.
You guys agree?
None. Yeah.
Group number 5, problem number 6. What was the problem?
7k squared plus 9k.
And how'd you factor it?
Just 3k.
Done? Okay. What was problem number 5? And why was he hard?
Because there's 7 on filter.
Okay, it had a number in front. So what's the problem?
7x squared minus 31x minus 20.
Oh.
Oh my gosh, disgusting.
I just need a little bit of advice. I asked this yesterday, not yesterday, sorry, it was like first chapter sometime. But I didn't get any positives from you guys, and yet from my regular pre-cal, I think one of the teachers last year taught the box. Did anybody teach the box last year?
Oh, that was Mr. Parker.
Okay.
There's, oh no, that was multiplying polynomials too.
Was it just multiplying
That was just
polynomials?
multiplying polynomials.
Okay, you didn't do factoring with the box. Okay.
No.
I just wanted to make sure, because I knew that you guys, anyway, I was hoping you could help me a little more than taking time and trying to figure it out from them. How do we factor with a number in front? Some brains can see it. That's how I do, I guess and check. I already showed you that. You could do quadratic formula to find the zeros and then somehow make them factors. It's like working backwards. We could actually kind of do completing the square the same way. Or, since we need to be kind of quick at this, factoring if it's possible, which do you guys figure out? Is it possible?
No.
Some say no, some say yes. Which means, oh, maybe it is. We have to have a way. And the way is, what were these two numbers supposed to multiply to? The last. What were these two supposed to multiply to? The last. What were these two supposed to multiply? These two. This one, okay, that's lame. Coming back. I need to end up with parentheses that multiply to be 20 at the end, but I need first ones that multiply to be 7. And then somehow the 7 and the 20 is going to get put together with the outer and the inner. So we actually, instead of looking at just the 8 or just the 18 or just the 14, we have to look at factors of negative 140. Why? We take the 7 times the negative 20. If you need a strategy as to how to attack this problem, whenever there's a number in front, I'm guessing you don't like guess and check. So therefore, the other way to do it would be to multiply the first and the last and then say, hey, what possible factors of negative 140 are there? And the reason that we can eliminate and not go through and write all of them is because we need the two factors to add or subtract to be who?
Negative 31.
The one number that's remaining. For instance, 1 times what is 140?
140.
1 times 140. Well, that's not going to make 31. Adding or subtracting? Okay, 2 times 70. That's not going to make 31. Adding or subtracting. That'll make 68 or 72. 3 times, well, 3 goes in to 14. 4 times, there's a 1 left,
35.
a 2 left over.
Yeah, no.
3 doesn't go in. We can try it. No. 4 goes in. Huh.
3 times
4 goes in
3.
35 times.
Shoot.
What was my strategy? This is what Luca was doing on his calculator. Divide by 1, 1 times what? Divide by 2, 2 times what? Divide by 3, didn't go in, forget him. Divide by 4, 4 times what? And then say, oh, if I had a negative 35 and a positive 4, couldn't that
Oh, then you split.
Potentially.
make the 31?
Yeah.
Does that make sense? My ones that were
It
lost,
does.
right? And then we bring down the rest, like the minus 20 is still there, and so is the 7x squared. What is this method called? Grouping. And if a function can be factored, you will always be able to, this is a good thing for those of you that are like, I hate these. Listen, you can always figure out how to split up the middle term using factors of the first times the last. If it's possible to be factored with rational numbers, you'll always find it. And then if it's impossible, well, we're either going to be able to use our calculators and maybe find the zeros, or we'll be able to use the quadratic formula if we're finding zeros. Now what? Grouping says,
You can reorganize first.
Right.
So
You
can
can
have the
reorganize.
7 and 35 together.
Splice.
you can reorganize, but let's just say that you didn't think about reorganizing. Some of you would switch this and say, hey, that's easier. That's totally fine. But just in case you don't think about it, does it still work? If we take out an x, what do we get?
7.
Now remember, we're grouping. We're looking at them separately, piece by piece, okay? Looking at the first piece, what's in common? X. What's left?
7 plus 4.
What's in common?
5. Negative
5.
Negative 5. Let's take out everything that's in common. 5 into 35 is 7. Plus, we took out the negative 4. And then grouping is working if I have 2 common factors, which I do. That becomes 1. And the other is from what's left. You're basically taking out the 7x plus 4 and who remains. Dun, 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 dun. Does that make sense though?
Yeah.
Okay. Now, I said, and some of you guys were able to get part of the way in your groups, possibly. But hopefully that helps if you weren't able to get as far in your groups. Because then I wanted you guys to go ahead and try number 7. Hold on. We need a little more room, so it needs a little bit harder, huh? It's the same thing for 9. Someone give me the problem for number 7.
7x squared
Keep going.
minus 45x
Perfect.
minus 8.
Minus 8?
28.
Ooh, it's a little bit rougher.
Really rough.
Now, hold on. In 1 through 6, most of you were able to get 5 right, yeah?
Yeah.
I don't mind those odds. But we have more on the page, yeah?
Yeah.
Okay, so we're trying to figure out everything else. Good job on getting hopefully 5 out of the first 6. So let's see if we can work together to figure out this last one. I need to scroll down a little bit. You tell me, where do I start?
A times C.
Multiply. Who times who?
A times C.
A times C. First times last. Now, I know some of you are so tied to your calculators, but we got this, right? 7 times 8 is 56, carry the 5. 7 times 2 is 14 plus 5. Some of you forget how to do it the old-fashioned way. And that stumps you on things like possibly tests where no calculator is allowed. Coming back. So what is 7 times negative 1, or negative 28?
Negative 1.
Technically negative. Which means in the factors, one sign will be positive, one will be negative. Divide by, well, this needs to add to be 45, right? Okay. Divide by 1. 1 times 196. That's not adding and subtracting to 45. 2. 2 goes in. 2 goes into 19 9 times. Carry the 1. 19 minus 18, 16, 8 times. Oh, no. 3. 3 goes in. 3 to 19 is 6. Carry the 1. Oh, 3 doesn't go in. 3 doesn't go into 16. 4. 4 goes in. 4 into 19. Remember what I'm doing, guys, is the good old-fashioned 4 into 19 is 4 times, yeah? Hence why I'm going to go ahead and write 4 times. Then you subtract 4 times 4 is 16. 36 remains. Oh, hey, that does go in. I found it. Did you?
Yes.
So, to make negative 45, question, which one's going to be negative, which one's going to be positive? Now, if you want to make it a little bit easier on yourself, you might start writing the negative number first. Fewer mistakes will occur if you write the negative number first. I need 1 negative, there he is. I need 1 positive, and there he is. And then the positive number second. Now what? Group it. What's in common for the first? It's x and, you see what I was doing? Sorry. Should have asked first. Pull out the 7 and the x, and I end up with? Got it. What comes out from the second? What's left? So what does that tell me? If they asked us to equal to 0, I'd keep going. But if they just say factor, you can stop. Remember, if they don't say find the zeros, you're not going any further. You're stopping right there. Okay, I know, it's a struggle. Some of you are so excited and you're just busting through. Pens down, stop. Finish this worksheet for homework. Okay. Ah. I only left you 3. Come on, you can do this, right? All right, let's go ahead and go back to our... Oh, here they are. I'm in the notes. We'll talk about the rest of them tomorrow. First of all, I asked you the following question. Composition books out. If I see anyone factoring when you should be paying attention, I might just give you a blank one and say start over. Put it away. Put it away where? In your spiral. Where in your spiral? In a nice little pocket so you can have it with the rest of your homework to do tonight. What? That's why we got a spiral with a pocket. And if you didn't get a pocket, well, you better keep that folder with you and not lose it. Okay, here we go. Keep out the other worksheet, though. We haven't talked about them yet, right? Okay. This question. Have you guys read the title of the worksheet, the second one that you got? Go to the front where it says name, period, group number, etc. You got the one worksheet. What's the title of that worksheet?
Honors Pre-Calculus worksheet for geniuses. Thank you.
There isn't a title, is there?
Honors Pre-Calculus.
Honors Pre-Calculus. Oh, kind of. I want you guys to put right underneath Honors Pre-Calculus worksheet, I want you to put Max Min worksheet. That's how I name it, and I guess I didn't put it. Max Min worksheet. What does that have to do with the question that you guys were faced with at the very beginning of today? Hey, it says Max or Min. We're going to get there, but first, from the examples we talked about yesterday, the first one, what did you guys decide? This vertex, 7 halves and negative 1/4, is he a max or is he a min, and why? What group wants to take it? Let me see hands. Karina, go. Say it one more time, because the function is?
And how can you describe that in the right words?
This works. How about that?
Like
Since the
highest-
x squared term is positive, we could say the coefficient of the highest degree term is positive. A better way of saying it possibly, since the leading coefficient. Who do I mean by leading? The one of the highest degree term. So the proper way would probably say the leading coefficient is positive. But just to, few of you, and it's going to happen on this worksheet probably at least once, you think leading coefficient positive, it's a max. Why do you think that? Yeah, positive, right? Like positive, it's something high, positive numbers are up. Why does a positive leading coefficient mean a minimum? Because the parabola is the normal concave up like a cup. But concave up like cups have what for vertices? Minimums, right? Does that make sense? So if the leading coefficient is positive, it's a normal, like the parent function, positive x squared. It's concave up like a cup, which has a min. So what I hope to do today is to cement a few things in your minds, like when facing four quadratics, the question, is the vertex a minimum or a maximum? To make your brain jump to the graph and think concave up or concave down and be able to assess for surety, completely positive, that your answer is what it is. Now this one is going to be a minimum, I totally agree. It doesn't matter whether the signs are positive, negative, whatever. The parabola is concave up like a cup, it has a min. How about this one? Same thing? The exact same thing?
Probably not.
There's a number in front, but
It's still positive.
what is the sign of the number in front? So we could say basically, since 3 is greater than 0, but what am I really saying? The leading coefficient is again, I can't spell coefficient, that looks like coffee. It's greater than 0. What kind of concavity do I have? Attach it in your brain. Concave up like a cup, which has a minimum. Yeah? So what would it take for a quadratic to have a maximum? A negative leading coefficient, which means the graph will look like negative on the outside, flipped vertically. Concave down like a frown, and it's going to have a max. It's going to have a max. Let's keep going. This is what we didn't get yesterday. This is what we didn't get yesterday. Low battery mode. We should see. This is what we didn't get yesterday. Quadratic functions. Yes, I know. That's what we're talking about. Graphically. Oh. They're putting it all snazzy-ish. Putting the definition of the quadratic, ax squared plus bx plus c, not even worrying about the standard form of the vertex. They're saying if a is greater than 0, okay, whatever. The top guy, the top number, the leading coefficient. If he's positive, we'll always have a concave up graph. We can also say it opens upward. And opening upward will always have a minimum. And the second one, using the definition, if the a is less than 0, that's the snazzy way of saying it. Basically, leading coefficient is negative. The vertex is the highest point. Hence, we have a maximum.
Our axis is always going to be x equals something, since we're dealing with quadratics.
Since we're dealing with quadratic functions as opposed to quadratic relations.
So, here's
If the
asking
x
for
is-
the axis of symmetry.
They should all be x equals as long as y is by itself, which it is in all.
And this is going to be the x of the vertex.
Yes.
Okay.
I should just stop taking notes.
Sorry.
So hold on, we already talked about the vertex, right? There are two different ways of talking about the vertex. He's either HK if we, how do we get HK? If we go to standard form, if we complete the square. Or negative b over 2a f of negative b over 2a. What am I trying to point to in that one? The shortcut, yeah. The quick little plug-in where you can find the x pretty fast, but it might be harder to find the y. So either completing the square, that was the HK from the first one, or our quick little shortcut, but we can find the shortcut X, the H, pretty fast. Plugging in to find the K can kind of be yucky. It just depends. But whatever our vertex is, the vertex doesn't determine whether it's a maximum or minimum. In and of himself, he has no power. He's powerless to figure out a max or a min. But based on the context of who he's a vertex for, if A is less than 0, if the leading coefficient is negative, I have concave down like a frown, which has a maximum, and where? At the vertex. And if A is greater than 0, a positive leading coefficient, I have a concave upward graph, and hence at the vertex I have a minimum. So where is the max or the min? At the vertex. And how do I know which it is? Look at the sign of the leading coefficient, visualize the concavity, and make your determination. Make your determination. Once again, the vertex doesn't determine, he can't determine for himself whether he's a max or min. We have to look at the entire equation, look at the leading coefficient, which is the coefficient of the x squared term. Based upon the signs, think about concavity. Based on concavity, go ahead and state what the vertex will be. Now, axis of symmetry. Hold on, look at your pictures. Axis of symmetry. That's the line about which the parabola folds, right? Like a butterfly.
Yeah.
Axis of symmetry for a normal butterfly would be like his middle, right? Same thing with the parabola. Axis of symmetry is the middle, the line about which I could fold, yeah? Girls, maybe guys too, I don't know. When you were in elementary, if you want to make a really nice heart, and maybe you still do for like younger siblings or for random projects, how do you make a heart? You fold it, right? And then you draw, like on the corner of the part that's folded, right? You draw like half the heart, and then you cut it out, and then, oh, look, it's a nice symmetric heart, yeah? Same thing here. Axis of symmetry is the line about which we could fold it, and it'd be perfect. But Luca already pointed out, what kind of lines are the axes of symmetry for any parabolas of the form y equals ax squared plus bx plus c? X equals who? He goes through the vertex. So x equals who? Well, the x of the vertex. Just steal them, whatever. Don't have to do anything extra or special. And if we want to do our quick little shortcut, what else could we technically say?
X equals negative b over 2a.
So we could say x equals h if we're doing the completing the square way, which is necessary, and we do have to practice and get good at it. Or we could also check with negative b over 2a. Or if possible, if the directions don't say complete the square, we could kind of cheat and use negative b over 2a. A couple more seconds. Did we almost have it? Let me see what's next. Is it your worksheet? And the worksheet. Okay, ready? How do we sketch the graph? Use our graphing calculator. Nope, that's not sketch. That's use your grapher too. How do we sketch? Make a random table and just guess x's and hope we're right. No, awful. That was algebra 1.
Find the axis.
Identify the vertex and the axis of the parabola. They're telling you how to start. Now technically there are a few different things we could do, like x-intercepts, y-intercepts. But first of all, let's identify the vertex. How? Okay, we're going to cheat just a little bit. The shortcut would say, how do we find the vertex? Negative b over 2a, and then take that and plug it in to find the y value, right? Okay, just showing you how the shortcut works because it can be a great double check to make sure you're good. Who's b? Negative 8. All over. Who's a? 2. Does that make sense?
Yes.
Check it out. Make sure we're tracking. Make sure we're tracking. Negative b over 2 times a. Oh. Now how do we find f of, well, hold on. Who's this answer anyway?
Negative 2.
Negative 8 over 4.
Negative 2.
Okay, where to plug -2 into?
The function.
Oh, gross, right?
Totally.
So we can go ahead and plug in 2 times -2 squared plus 8 times -2 plus 7. Then we plug in, this shortcut's getting not so short anymore. But it's still a way of checking, right?
Yeah.
So we have -2 squared is 4, 4 times 2 is 8. Hopefully you never do any mental math wrong. 8 times -2 is -16, or minus 16, plus 7. My non-mental mathers, do you see that 8 is positive and 7 are positive? Is positive?
Yeah.
Steal your 2 positives. What's 8 plus 7? 15 minus 16. Look, that's how mental math works. Is that our vertex? Why, yes, indeed it is. Problem is, though, let's practice completing the square real quick. Just real quick.
Let's get it, boys.
Complete the square. What's step number 1?
Factor out the leading.
Pull away the leading coefficient. If it's anything other than 1. Do I have something other than 1 in front?
Oh yeah, man.
Yeah. Let's pull out that 2. Pull out the 2. From what? Do you remember how many things we pull out the 2 from? Not all.
Just
Who don't we like? We don't like the 7, right?
We hit that boy.
So pull the 2 away from the x squared, pull the 2 away from the 8x, but then leave the 7, remember? He doesn't help. Maybe I can factor, but that's for zeros. But then if I'm going to fill in the blank here, what else do I need to have?
A blank over there.
A blank over here, right?
Balance it.
Now how do I find that magic number to put into my blank?
Just go the half of the.
Take the 4, cut in half, and square him. What's 4 over 2 squared?
4.
4, right?
Mm-hmm.
4 over 2 is 2. 2 squared is 4.
-8.
8, right?
Yeah.
Does that make sense? Perfect. Now what? Factor. Simplify. Make it look pretty, huh?
By the outside coefficient.
Who? It's going to be x. How do I know it's going to be a plus? Everything's positive. And then who was squared to get 4? Who was squared? 2. You can always steal that number. What's left out here? 7 minus 8 is? Hey guys, does this match up with the vertex that we just found up here?
For once, it looked easier.
I know, right?
We vibing.
See? Same thing. Kristen.
I'm just confused, how did you get the 2x plus 2 again?
I have to factor this,
Yeah.
and every perfect square, because we're making it a perfect square, every time the perfect square, I can say who was squared.
Oh, the 2. So that was from the outside.
So we got it from, no. Who was squared to make 4? We got it from there. So technically, we got it from what we had before we squared. Does that make sense?
Yeah.
From cutting the middle coefficient by half.
Okay, I forgot, why do you divide it by 2 and then square it?
Because for a perfect square,
Oh, so the purpose is to find the, okay.
yeah, every time, hold on, give me a quick sec. Just in case it helps. Every time you have a perfect square, and it doesn't matter what the number is, when you FOIL, hold on, you're always going to end up with double the number. So if I want to get back, I have to say, wait a minute, you're double. I have to cut you in half. And we do that little squared in order to fill in the blank, because we're trying to fill in that blank. So we cut it in half and square it to get that. And then when we come back, we say, hey, what was the half to fill in? That's basically. We didn't finish though yet. What were we supposed to use all of this to do? Sketch the graph. Okay, so what do we have? We have a vertex at, we have a smart board that's misbehaving. Okay, we have a vertex at -2, -1. Well, that's fun. Now what?
If you equal x x plus 0, that's going to be x.
What do we know about him? Leading coefficient is positive. So not only do we have a vertex, but we also know that positive, he's concave up like a cup, which means that this is a minimum. Well, that's nice. So we know it's somehow going up. But do we know how skinny or wide he is? Huh. But if he goes up, what's he going to hit?
Y-axis.
He's going to hit the y somewhere too, but isn't he for sure going to hit the x?
Yeah.
And if I have 3 points, can 3 points establish a parabola? How many points did it take for a line?
2.
Only 2 points. For a parabola, we want 3. But we already have 1, so if we find our 2 intercepts, we're solid. How do we find intercepts again?
Factor the parent function.
I wonder why we practice factoring today. X-intercepts. Set the original one equal to 0. That's one way. Can we factor that one? I hope so. Multiply first and last if you need that help. 14. What factors of 14? 1 and 14, not 8. 2 and 14. 2 and 7,
Oh,
not 8.
yikes.
Uh-oh.
Boy.
Oh, wait, just kidding. I thought it was 16. Right.
Is
We
this
can't factor.
a function that can factor to a nice rational number?
Quadratic formula.
You could do quadratic formula, or
Hit me up.
don't we have it? Now, wait. If we get factor, wouldn't we be solid? We graph our 2 points and we're done?
Oh, yeah,
Well,
totally.
connected. Don't we have the completing the square just ready and waiting? So why don't we set him equal to 0?
Boy.
Because quadratic formula is, isn't quadratic formula completing the square?
Yeah.
So if we already have him, why make our brain hurt itself by trying to remember the song? Like, I don't know what the song was, so I have no clue. Coming back, do we need to know the song if we already completed the square? How do we get x by itself? Oh, add 1.
Just that good.
How do we get x by itself? Oh, divide by 2. How do we get x by itself? Plus or
Minus.
oh.
Ooh. Juicy. Yep.
What on earth? Good pulled pork. And chili. Keep going. How do we solve for x?
Subtract.
Guess what quadratic formula would have gotten you if you had known how to properly make it all nice and simplified and pretty? That. Now, if you really like quadratic formula, I guess you could do that instead, but I kind of like the plus 1 divided by 2, plus or minus square root minus 2, done. Woo! My brain follows that better. We already did all the work for completing the square. Why go back and have to do the quadratic formula? Now, who is that?
It's about 3.41, blah, blah, blah. And
What's the square root of 0? 0. What's the square root of 1?
1.
This has to be somewhere in between that. So it's negative 2-ish, but in a little bit. And it's 2-ish the other way. 1, 2, I did not make this very nice either, did I? You may take marks to be a lot bigger.
Whoa.
Okay.
Because you put the square root.
Okay. Negative 2 plus a little bit is going to actually, with a positive, going to make it a little bit less than 2. So I can go 2 over. And instead of going the full minus 2, it's going to be less than a little bit. I don't know, somewhere in there. And then instead of going the 2 back, it's going to be in a little bit. Now, if you really, really want to, could you plug it in and find a decimal? Yeah, but what are we going to do anyway? Approximate. So anyway, there we go. Long story short, we have a parabola. It's fairly accurate in the sense of we at least know in between what numbers it is on the x-axis, and we know the vertex, and we say, ta-da, there he is. Okay, that was something random to talk about completing the square. Homework, due tomorrow. But, do you have the worksheet?
Yeah.
Let's peek at him.
Oh, there's a back.
I actually tonight, listen. Remember last night you were supposed to start your 2-1 homework? Yeah. Okay. How many problems do we have left to factor? Like 3. Some of you 2 or 1, maybe 0 if you were working really hard. Cheaters. Coming back. This worksheet, I want you to go ahead and, for tonight, just try whatever we don't finish on the front side. Okay? Look in the back. Is there a back?
Yes.
Yes. We're not going back. Not tonight. Okay? Just the front. Is this your first problem?
No.
No. But is he a lot like it?
No.
Are you sure?
Yeah, pretty much is.
Yeah, I'm looking. You're given an equation. It wants you to graph it. And it wants you to find the vertex.
Oh, that part, yeah.
State it as a max or a min. Actually, this is the bottom part. And then find the axis of symmetry, and then the zeros. Okay, so it's part of it. That's part of it, right?
Good job.
How do we find the vertex?
Complete
Complete the square or
or the
shortcut.
Shortcut.
Cheater shortcut, right?
Yeah.
But what do you notice about your 1 and 2 and 3? It's already given to you in standard form. Can you just pull it out?
Yeah.
Oh.
Gorgeous.
So you already have the vertex.
And
You already have the axis of symmetry. It's the x of the vertex. What's the hard part? Find the zeros. Why? Because to graph any parabola, how many points do we really want?
3.
3. Vertex, pull out your HK. Zeros, set it equal to 0 and solve, or use the quadratic formula, or distribute it all, get ax squared plus bx plus c and try to factor another way. Ugh.
Don't you
Don't
only
do
really need 2 points?
Kind of. If you can have a third, you can use the symmetry to get it over, but you want 3 points with that. Now hold on. What's a little bit rough about section number 2? You see 4 and 5? What's the one difference? You're still finding the vertex. You're just saying max or min.
It's in a
You have to get it in standard form. Or use the cheater shortcut. You get to choose on 4 and 5. Sound good? Okay. Now hold on real quick. On 4 and 5, can we just figure out what goes in the blanks? Vertex. Oh, for HK. The function has a, what do you put? Oh, max or min. Value of.
Your minimum or maximum value.
Value of. Y value goes first. X value goes second. We'll talk about the worksheets tomorrow and check the homework and see how you're doing. Guys, practice on quadratics tonight. Bye, guys. See ya. If you have questions, come in, let me know. Lunchtime after school.